Let's start the lecture. So, as the content discussed in the fourth week of the class, um, various collection equipment which are used for the collection of solid waste. For example, hauled container systems and stationary container systems. In hauled container systems are basically those systems um, where the the hauled container can be moved from its location with waste. These hauled containers are designed. These containers are designed to be hauled because the location where these containers are used, normally those locations will collect a huge quantity of waste. So it is not feasible or possible to um, lift those lift those containers to make them empty into the trucks. So that's why the whole containers are designed in such a way that they collect a large amount of waste and they can be hauled from their location to to the transfer station or disposal site wherever seems fit. So in haul container system, the containers collect waste at a particular location, normally commercial and C&D waste. In commercial location, the amount of waste collects is the amount of waste collected in that location for commercial location is in large amount. Similar is true for C&D waste. The amount and weight of the waste is very high. That's why hauled containers are used for both the purposes. Second is stationary container systems, which includes residential and commercial systems. So in stationary container systems, basically they stay at their place, and because they are normally used in residential or commercial places where the individual container won't have much weight. It can be lifted and turned into the collection truck, emptied into collection truck. That's why these containers are normally stationary. They need not to be moved or hauled from their specific location to be emptied. Further going into stationary container systems, the emptying of the stationary container system can be in two ways, either it is manual or mechanical. So the manually loaded systems basically when the collection truck comes to collect the waste from residential area, the trucks can be of two types. Whether it's manual or mechanical. In manual system, there will be one person who will be there to uh, take take the container, the waste containers placed in the residential area, and those containers can be emptied into the collection truck. These emptying of the dustbins can happen from side, as the name suggests, side, and rear loading. Rear loading means the emptying from the back side. Normally, these trucks have compaction systems so that in a one go they can carry more amount of waste. Because if the volume is reduced, you can carry more amount of waste in the same space, and in that way you can reduce the number of trips of trucks. So that directly influence the cost of the collection system. So as we know, collection is the most cost intensive process. So in mechanical system, the loading is done in three ways. Front is First is loaders, front loaders. The loading is done from the front side of the truck. Basically, it has a type of lever arm sort of thing which lifts the waste container and it lifts the waste container in this way and it dumps the waste in the truck. And side loader is same as that of manual loader. Only thing is there will be a mechanical mechanical arm which will do the side loading. In grappling movement has basically more degree of freedom for movement. It can just pick up the dustbin, just like we can pick up the glass, and it can just dump it into the container, the collection truck. Most of it's like works like an robotic arm sort of. So further, um, the diagrams for the different stationary container systems were similar as shown in class. Uh, so uh, for like to fund these collection systems and all the human resources involved in the process, uh, they normally bills are collected in terms of utility bills or property taxes. The most efficient way is in terms of utility bills, where the whole amount is collected specifically for solid waste treatment, similar to the sewage and water supply and electricity in the same manner. Uh, a certain amount can be collected for the sewage solid waste treatment. So normally they uh, uh, pay like the method of quantifying how much a person should pay. There can be two ways. One is in the terms of weight or mass. Second is in terms of volume. So both the methods have some advantages and disadvantages. For example, if we are collecting measuring in terms of volume, so this collection in terms of volume is more simpler. But people can do compaction in a container because for in volume you just sell a particular dustbin or container to collect waste of certain volume. So based on that you can directly quantify how much waste is thrown to the truck, collection truck. But if compaction is done, then more amount of waste can be fitted in the same dustbin. So that makes things a little more complicated because the amount which is paid by the person is less as compared to how much waste the person is dumping when the collection is done in terms of volume. Mm. There's some advantages also, like it is easy to administer and it is less expensive because you don't need a particular compact. You don't need. Second system is on the basis of weight. In weight system, you can uh, you can uh, basically compact the waste and reduce the volume of the waste. And in the same container, you can store large amount of weight in waste in terms of weight uh, by compaction as well as so because the waste collection is done on the basis of weight, so it will be fair for all people because uh, the amount which will be charged to a particular person will be specific on the base of weight, which will be calculated by weighing system or in mechanical system. The lever arms can have sensors to estimate the weight before emptying and after taking the weight after emptying so that the difference can give the weight of the waste. So this system is more fair to the public because it gives a better idea of how much waste is generated by a particular person, and based on that fair price should be paid by the uh, person who's generating the waste. But, but the disadvantage is there will be additional capital cost uh, for the system because there will be need of sophisticated sensors and lever arms for the estimation of weight. So in that sense, there will be additional cost, and you need more administrative people for the billing purpose. So based on the content studied in the week 4, there are few numericals, and then further we will do some um, theoretical or MCQ questions based on the content we read on from week 1 to week 4. So this is the first question. A town in West Bengal with 5 lakh population generates a pointed kg per capita per day of MSW. How much MSW is generated in the town? So read this question and take take few minutes to solve the question, and then we can solve and we will solve the question together, or I will share the solution. let's solve this question. So, a town in West Bengal with 5 lakh population generates 0.8 kg per capita per day of MSW. How much MSW is generated in the town? So, for calculating the answer of first question, we know the per capita generation, which is 0.8 kg per capita per day. If we multiply it by the total population, we will get how much waste is generated per day. So, zero point 0.8 into 5 lakh will give us 4 lakh kgs per day. This much amount, 4 lakh uh, kgs of waste is generated per day from this town. So this will be the answer for the first question. For second question, how many trucks would be needed to collect the waste twice weekly? Twice weekly. Mm, Each truck has a capacity of 3.5 tons and operates 4 days per week. Assume that the truck averages 2 loads per day at 65% capacity. So for the calculation of this, for this question, we need to calculate how much waste is generated per week. So from the above question, we have how much waste we generate in one day, which is around 4 lakhs kgs. So 4 lakhs into 7 will give us, which is equal to 28 lakh kgs will give us the amount of waste generated in a single week. Now we have, as we have the amount of waste generated in one week, now we need to calculate how much our truck can carry in a one trip. So that can be calculated. For that, we have given that in a single trip, the truck will carry waste up to its 60 only up to its 65% capacity. So here it is given how much is the actual capacity of the truck, which is around 3.5 metric tons, which will be around 3,500 kgs. So 60.65 into 3500 will give us how much amount of waste a truck can carry in a one trip, which will be equal to 2275 kgs. Now we have how much amount a truck can carry in a single trip. But we have also given additional information here that truck operates 4 days per week and assume and every day the truck carry 2 loads. So in total, in 4 days, a truck will be working for around 8 trips. So 8 into 2275 2275 will give us the base capacity of one truck for whole week. So that will come out to be 18,200 kgs. If we multiply 4 into 2 into 2275. So we will be getting an amount equal to 18,200 kgs. Now we want to calculate the number of trucks. So we just have to divide the waste generated in a week, which is around 28 lakh kgs, divided by 18,200, which is the capacity of one truck for a whole week. So that will give us around 153.8 trucks, which can be rounded up to 154. Now the last question is, if the town starts a recycling center and manages to divert 35% of MSW by recycling, determine the waste mass of MSW that enters the landfill. So this question is very simple. We already know the answer for the for A question, which is around 4 lakhs kgs. So, and out of 4 lakh kgs, 35% is going to MSW. So still, 35% is not going to landfill. It's recycled. So that means 65% of waste is going to landfill. So just multiply 65%, which is 0.65 into the waste generated in one day, which is around 4 lakh kg. 4 lakh kg. So 4 lakh into 0.65 will give us an amount of 2.6 lakh kgs. So that will be the amount which is will be going to landfill after 35% of MSW is recycled per day. This is the answer for this question. Moving on to next question. This is the next question. The population of city is 10 lakhs. Assume per capita waste generation is 0.6 kg per day, and then the waste is combusted, and there is no recycling facility at it. So I estimate the landfill area needed to handle 1 year's municipal solid waste for landfill density of 593 kg per meter. This is the first question. There are two more questions for the same, two more sub questions for the same question. We'll try the first question. Let's do these questions together. Population of the city is 10 lakhs. Assume per capita waste generation it's 0.6 kg per day, and 10% of waste is combustion. There is no recycling facility at that. So, and estimate the landfill area. So first we have to calculate how much waste is generated. So for that we have to multiply 10 lakhs into 0.6, which will comes out to be 6 lakh kgs per day. And out of that 6 lakh kg, 10% of waste is combusted. So 6 lakhs. So still 10% is combusted. That means 90% of the waste is going to landfill because there is no recycling facility. So you have to 6 lakhs into 0.9, which will give us 5.4 into 10 to the power 5 lakh kg per day. 10 to the power 5 kg per day. Or 5.4 lakh kg per day. So now we have to calculate how much, estimate the landfill area needed to handle 1 year's municipal solid waste for landfill density of 593 kg per day. So we have the density, then we can directly calculate the volume. So just divide the amount of waste, which is 5.4 lakh kg per day, and by uh, the density given, which is 593 kg per meter cube. This will give us the value of 593. This will give us the value, which is around 910.62 meter cube per day. But here the value is asked in meter cube per year. So just multiply the value with 365, which will give us around 332,377.7 meter cube per year. So C, for this question, C is the correct answer. Next question is, if the 20% of the cell volume is used for cover, then calculate the volume of cell needed. In this case, the question is saying that if the 20% of the cell volume is used for cover, then calculate the volume of cell needed. So the question is saying that the one cell uh, which we are using uh, for filling the waste in the landfill. So if we include the volume of the volume of the cover also, then what will be the volume of the whole cell, including waste as well as the cell cover. So if 20% of the cell cover is used, so out of total volume, if 20% is the volume of the cell, then what we have to do is the volume which we have calculated in the previous question, which is around 332,377.7 meter cube per year, is divided by zero point 0.8, and if we divide it by 0.8, which is representing that there is only the 80% of the volume. So the new value what we get is 415,472 meter cube per year, which is C option. C option is the correct answer for this question. The third question, calculate the landfill area required to handle 1 year's municipal solid waste. If there is no waste is combusted and no cover is provided. So in this question, basically, uh, initially we reduced the total amount of waste by 10% as 10% waste was combusted. So in this case, we don't have to reduce the waste by 10%. We will use the actual value of 6 lakh kgs per day to calculate how much volume will be needed. So directly we have to take the 6 lakh divided by density 593, which will give us the meter cube per day value. And now we have to multiply it with 365. So the value we get is equivalent to 369, 369, 369, 308.6. The first option will be the correct answer. Next question is determine the number of 7.5 meter cube containers required per week after compaction for a colony with 2000 houses, 3 people per house. Generation rate is and the compactor specific weight is 20. So this is a similar type of question as we done previously. Just give it a try. Take 4 5 minutes. Try to attempt the question. Then we will do it together. For the next question, we have to determine the number of 7.5 meter cube containers required per week after compaction for a colony with 200 houses, 3 people per house. The generation rate is zero point 0.6 kg per capita per day, and the compacted specific weight is 250 kg per meter cube. For this question, we have to calculate the number of containers. So first, we have the volume of the container. That means we need to calculate the volume of waste generated per week. So for that, uh, we have we have 200 houses. So 200 houses into 3 people per house. So this will give us a total number of people, which will be around 600 people in a particular colony, and each person can is generating zero point 0.6 kgs. So if we multiply 600 with zero point 0.6, it will give us around 360 kgs, 360 kgs per day. And we need to calculate for 1 week. So 360 into 7 will give us 2520 kgs per week. 2520 kgs per week. So uh, this total amount of weight we are getting at the end of 1 week from 200 houses is around 2520 kgs. And if we divide it by 250, we will get the volume of the waste. The volume will be around 10.08 meter cube, which will be generated in a span of a week. So now total volume of waste is 10.08 divided by the volume of one container is 7.5, which will give us around 1.344 containers, which will be rounded off to two containers each week per week. So we require at least two containers of 7.5 meter cube to accommodate the waste generated from 200 houses, where each person is generating a waste of zero point 0.6 kgs per day, and the waste is compacted to a density of plus weight of 250 kg. So correct answer for this question is C. 2. This question is similar to the question we attempted previously. Here we calculated the number of trucks uh, based on the population and per capita generation. We calculated total waste, then based on number of trips we calculated how much trucks we need. Similar type of second question. Second question was based on landfill, how much area is required. Based on how much recycling and recovery we are doing. And third question was similar sort where we are calculating how much containers we need. So all these questions, first and third question is based on uh, the collection system, design of collection system, how much trips of trucks we need to perform and how much containers we need to keep in a particular area. The sir will teach the next part in the fifth week, the content in the fifth week. So the numerical based on the fifth week content will be in probably in the next lecture. Till now, whatever I taught till fourth week, based on fourth week, these were some numerical questions. We have further numerical questions. Like this question is based on the content of third week, where you have to calculate the percentage of carbon in the food waste. So here we have two types of waste. We were generating a mixed waste stream which contains 60% of food waste and 40% of lignocellulose, which is a component in normally papers and cardboards and on those component. One of the component is lignocellulose wood. So apart from cellulose, hemicellulose, lignocellulose, which is comparatively non-biodegradable, very hard to biodegrade. So the chemical formula of food waste is given for both food waste and lignocellulose, and we have to estimate the percentage of carbon present in food waste. So uh, do you want to attempt it for take some time and attempt the question? Uh, S S alarme lu mangai. Am I audible to you? Do you want to attempt the question? Do you want to take some time and attempt the question? Yes. Yes. Yeah. Yeah. Please. Please try. Then we will see the solution. The person who will just join, we did some numericals, two, three numericals based on the uh, collection, based on the content studied on week 4, basically based on the collection design of collection system. So how many truck trips we need to do to collect a certain amount of waste generated from a particular area and how much dustbin we need to place. So those sort of question we did. So as you missed those questions, you can refer those questions from the video, recorded video. This is the question which we are doing right now. You can try this question and then we will do it together. No, C is not the correct answer. For first question, B is the correct answer. Let's see the solution for the first part. So in first part, we have to estimate the percentage of carbon in the food waste. So we need to calculate basically how what is the percentage of carbon. So initially what the rate is 37 into 12, which basically gives the how much weight of carbon is present. If 12 is the molecular mass, sorry, atomic mass, and 3.7 is the number of moles, and we multiply, we get the mass of carbon present in the food waste, and we divide it by the total amount. So this represent for carbon, this is for hydrogen, 16 into 1.8 is for oxygen, and 14 into 0.2 for nitrogen. So it basically gives us 53.8, which represents the percentage of carbon present in the food waste. So we have second part of that question. We will calculate the heating value of the food waste. We have to calculate the heating value of food waste. So we need the Dulong's formula. So Dulong formula is 145 into C plus 610 into H minus O oxygen by 8 plus 40 times of sulfur plus 10 times of nitrogen. So all the values are directly in percentage. For the first question, we have calculated the percentage of carbon, hydrogen, nitrogen, and oxygen. Uh, so we have values of we have for carbon we have 145 into 53.8 plus 610. Hydrogen is 7.76 minus oxygen is 34.9 divided by 8. Then we have 10 times of nitrogen, which is 3.4. So if we calculate this, we will get Do we have the answer for the second part? Okay. So for second part, use the basic formula. So if we place all the values, there is no sulfur, so sulfur percentage of sulfur is 0, and other values we have calculated. So if you put all the values, you will get 9907.3 BTU per pound. So for this question, D is the correct answer. And the fourth is calculate the heating value of the mixed waste. So now for this question, we need to calculate the heating value for mixed waste. So we need to calculate percentage for both. You need to calculate for lignocellulosic waste also. Then the amount of heat generated, we can just add and we can get the value. So try to calculate all the carbon, hydrogen, oxygen, nitrogen percentage for the lignocellulosic waste, and then we can calculate the heating value for the complete waste. Carbon percentage is coming 47.33%. For hydrogen, it will be 86.49%. For oxygen, it will be 44.54%. And for nitrogen, it will be 1.62%. So these values we can replace in Dulong's formula. It is 145 into 47.33 plus 610 into hydrogen is 6.49 minus oxygen 44.54 divided by 8 plus 10 into 1.62%. So the value we get here is 44.54 divided by 8 and 6.49 minus answer into 6.0 plus 16.2 plus 145 into 47.33. So the value will be 7441.7 BTU per pound. So answer for this question will be 7.41. Did anyone attempt the question? What your answer you're getting for the third question? Once we for third question, the value is asked is for mixed waste, and this 7441.7 is BTU per pound is for lignocellulose waste. So now for mixed waste, because composition is given in the question 60 40, so 60% we have to take the waste food waste component, and lignocellulose we have to take 40%. So for food waste we got value of for food waste we got value of 9907.3. So food waste is 60% of the total waste in the mixture of both lignocellulose and food waste. So 9907.3 into zero point 0.6 plus the value we got for lignocellulose waste is 7441.7 BTU, and we have to multiply it with zero point 0.4. So the value we get after this calculation is value we get is 8921.06 BTU per pound, which is equal to 8920 this question. Option A. So the answer for the third part is 8920.6 BTU. Solution is given here. This is the value we got for the food waste, and this is the value we calculated for the lignocellulose waste. And the the percentage composition of carbon, hydrogen, oxygen, nitrogen was, for carbon it was 47.33%, for nitrogen it was 1.62%, hydrogen 6.49%, and 44.54% for oxygen. These values we use in Dulong formulas to calculate this this value, heat value per pound. This will be 7440.475 BTU per pound for the lignocellulose waste. And because a mixture of both the waste is in the proportion of 60% and 40%, so 60% of the calorific value of the food waste plus 40% of the, if we take 1 kg of the waste, out of the 60.6 kg is food waste and 0.4 kg is lignocellulose. So in that proportion we take the heating value of both the waste, and then we add the value. So we get 8920.6 BTU per pound, which is option number A. So beyond these questions, we have some theoretical questions. This is basically a comparatively new question which we haven't done in the last three weeks. So these questions are basically from the content of last 4 weeks. So we'll do these questions. You can answer for each question. So the first question is, which of the following is the most favored method of waste management? So this question is based on the fundamental principle of redirecting of waste. Or so you can answer the question in the chat, and we can go through the questions quickly. Anyone wants to answer? Anyone wants to answer? So options given are recycle, waste minimization, disposal, and reuse. So the first first R is reduce. So first we try to do is reduce the amount of waste generated. So the B option, the waste minimization should be correct answer. Waste minimization should be correct answer. For the people who just joined, we before this we did some numericals based on the content taught by sir in the fourth week. Some of the numericals on like number of trips requirement for the collection of waste, how many dumpster or dustbins required. Based on that, we did few questions. So that can you can go through those questions in the recording or through presentation. Both will be uploaded. So now we are doing some questions, theoretical questions, uh, based on the last 4 weeks content. So second question is select the true statement from the following statement related to the greenhouse gas effect of methane and carbon dioxide. You can answer the question in the chat box and we can. Any answers for this question? Select the true statement from the following statements related to the greenhouse effect of methane and carbon dioxide.
It's D. CH4 is more potent.
G. Correct. CH4 is more potent greenhouse gas. Do I know how like how many times it is more potent? Methane. How much time more is potential as a global warming potential, which we estimate in terms of CO2, CO2 equivalent. So if we consider global warming potential for CO2 as one, then how much times it is for methane?
I think 12 times more.
25 times.
25.
Around 25 times more than that of CO2. The next question is diversion of collected waste from disposal sites to recycling center is a dash model of approach.
Is it cradle to grave?
Uh, cradle to grave. Cradle to grave will be landfill site.
Okay, to recycling center. It's cradle to cradle then I think.
Cradle to cradle. Cradle to cradle is
Because we
cradle to
are not
cradle. Yeah,
finding final solution of the recycler. It is still going on into the system.
yeah. Cradle to cradle is the correct answer. If it is all landfill, then cradle to grave was probably correct answer because landfill does a disposal. The activities including design, manufacture, purchase, or use of materials and products to reduce the amount of waste or toxicity of what is thrown away throughout the life cycle are called. Activities including design, manufacturing, purchase, or use of materials and products to reduce the amount of waste or toxicity of what is thrown away throughout the life cycle are called.
Source reduction.
Yes, source reduction. Source reduction is the correct answer. Next question is state whether the following statement is true or false. The natural decomposition of organic materials significantly reduces if heavy metals are present in the waste.
False.
Mm, mm, मतलब, sir, do you want to support your answer with like any justification? Why?
Natural decomposition of organic material significantly reduces if heavy metals are present in the waste.
Waste. Because sometimes, most of the time, presence of heavy metals is toxic to microorganism present in environment. Um,
Oh, okay. Yes, yes.
so, like on that basis, you can like sort of answer.
Yeah, on that basis it can affect. Yeah.
Mm. So, so the natural decomposition of organic material significantly reduces if heavy metals are present in the waste.
Then it
For
will
this,
true.
it will be true because presence of heavy metal may act in adverse way for the uh, growth of the
But
microorganisms.
but if
Yes,
the heavy material is very high, then normally it leaches out through the leachate only, na? Extra
it
moisture or
yeah, it depends based on what type of environment is it is getting. Um, like if we have some acetate and lead, so it forms lead acetate, then it may come out. So based on the pH conditions and what elements we are having in the leachate, um, so that will depend on those factors. Like directly, we can't say that if just heavy metal is present. If conditions are significant, then only it will leach.
okay.
You, next question is: you were appointed as a planning engineer for a solid waste handling project. You were given the task of determining the most expensive component of the waste handling project. With the knowledge gained through this process, what is the most costly part of solid waste handling? Through the whole supply chain, from the collection to till the treatment and disposal, which component of the solid waste management is most cost intensive?
It's collection
Collection
because
system.
transportation is costly, but I think that will be a part of collection only.
Collection system. Collection system is the most costly part. Um, the procurement of the trucks and manual labor, it require a huge amount of capital. As sir also pointed out in the presentation, that a single truck or
Actually,
man.
very dedicatedly routing system is required in this collection system.
Yeah, yeah,
Otherwise, repeated nature of job will be keep on happening, and that
yeah,
will increase the cost.
yeah. You can optimize
It,
normally operation
yeah,
research.
yeah, it requires a micro scheduling type of thing.
Yeah. Operation management is basically used to optimize the, you can optimize the route as well as number of trips, so that if you reduce even one trip, you uh, save a lot of cost.
Yeah.
And number of truck requirements, that also saves a lot of cost because sophisticated trucks cost around quarter million.
Actually, transportation, the major cost depends on the fuel consumption, and that is more.
Yeah,
It even
yeah,
affect the environment.
yeah, fuel cost, which also causes global CO2 emissions, greenhouse emissions, as well as the hardware itself is also very costly. So in collection, you have high initial cost as well as operation and maintenance cost.
Right.
The next question is identify the combustible gas that is released from the degradation of waste from the landfill.
Methane only, CH4?
Yeah, methane. Methane and majorly methane and CO2 also. Because in landfill majorly anaerobic degradation is happening. So in anaerobic degradation, methane.
Actually, Divyanshu, in that third assignment, na,
Huh?
one answer got wrong because I answered only one, because in the question it was asked like here it is the gas that is released. So
Hmm.
if when is there, then we select one option.
Hmm.
If R is there, we select uh, multiple option. So
Hmm.
in that question, same thing happened. Actually, three options were there, but
Hmm.
since the is was used, so I selected only one option. So got only
Okay.
0.6 marks.
Okay. Mostly, if such situation arises, normally there is a case where multiple correct answer is there. You won't
It
if
was
single.
there, but
Yes.
I knew that.
Yeah. But you didn't mark.
But I did because it was asked is, so I answered the most appropriate one. Just 1 minute, Divyanshu.
Yeah. Yeah. So moving on to next question. Which component of the municipal solid waste is used to prepare organic compost? Out of these four options, glass, metal, food waste, plastic, which of the component is used to prepare organic compost?
It's food waste.
Food waste. Mostly glass, metal, or plastic either can be recycled or can be reused. Food waste is the one component which is used to prepare compost. Compost is an aerobic process. Next question, among the following techniques, which isn't a waste to energy technique?
Composting.
Composting isn't a waste to energy technique. Correct. Next question is, which gas produced from landfill is called renewable energy source?
Which gas produced from landfill is called renewable energy?
This the answer once you answer like answer is methane only. But as sir also mentioned this, it is debatable whether we can call it as renewable or not. But for this instance,
The
the
methane cannot be renewable, na?
yeah. After burning methane, yeah, it's sir also mentioned this in class because it's debatable whether methane we are getting from landfill, whether it can be considered as renewable or not. Because in some sense, it is we're using it as a fuel, so it is basically we are reducing the amount of fuel production, but it can't be qualified as renewable. But for the for this instance, but it's obviously if we are reducing, we are extracting less amount of fuel. CO2 emission is able to reduce. We are able to reduce CO2 emissions in total. Sir also said it is debatable that whether we can classify it as renewable or not. But for this instance, this answer is methane. State whether the following statement is true or false. Source segregation is the key to develop a better solid waste management system.
Yeah, it is very much true.
Yeah. Source segregation is very, very important.
It is
because
a basic
yeah,
requirement actually.
yeah, and majority of the places in India we don't have good source segregation at like house level. We don't have source segregation. At some places, people although segregate their kitchen waste as well as the dry waste. As for example, in at my like in my hometown and at my home, my mother segregates the kitchen waste and the other dry waste separately. But the collection vehicle is doesn't have the
They mixes it.
yeah, it doesn't have a compartment. So mm, although some people might do it, but still because the vehicle doesn't have compartment, doesn't any difference. So this answer is true. Waste source segregation is very important. Expand LCA and RCR. What is the full form of LCA and RCR?
B.
B is correct. LCA is basically life cycle assessment. In life cycle assessment, you assess a particular product based on different boundary, as we discussed in previous question, which was cradle to cradle or cradle to gate. So based on the boundary, we assess a particular process, how much damage it can cause to environment in terms of global warming potential and eutrophication potential. Those are midpoint indicators. Then we also have endpoint indicators for the life cycle assessment, where it has three components. For example, human health impacts. In such a way, we can basically determine the impact of any process on human as well as our surrounding environment in terms of various parameters. And RCR is resource conservation recovery. Next question is life cycle assessment is used to determine the environmental footprint of any product. So we just discussed in previous question. This is true. The next question is acetic acid formed in the landfill degradation process is the substrate for which of the following specific microorganism? This we discussed in probably first and second week lectures where we discussed the anaerobic digestion process, anaerobic degradation process, which consists of four steps, which is hydrolysis,
Yeah, so
acido, yeah, acidogenesis, acetogenesis, and methanogenesis.
so during
So
an anaerobic phase, maximum acid is produced there.
no, anaerobic, these four components are basically anaerobic digestion, four components of anaerobic digestion, four step process. So acetic acid is majorly, it is formed in second step also, which is acidogenesis, but majority of acetic acid is formed in acetogenesis phase. And after acetogenesis, there is methanogenesis. So methanogenic bacteria basically use acetate as their substrate, as their food, and they produce methane gas. So here in this question, methanogenic bacteria will will be the microorganism which will be using acetic acid as a substrate to produce methane. So C will be the correct answer, methanogenic bacteria. Next question we have maximum BOD occurs in which phase of the waste stabilization process of land? This is also based on the same graph. So maximum BOD will be in which phase?
It's a before that acidic formation. I think beginning, it will increase.
Beginning will be low.
It will increase. I
As
think in the
in,
aerobic stage, it will increase, and once this acidic starts, then it starts decreasing.
in acidic forming phase, it will be increasing.
Yeah, it will be decreasing.
So we can see that in rough presentation also.
Yeah, I have opened that graph. Actually, BOD increases during the starting of the acid forming, and
Mm.
then it decreases.
Yeah. Correct answer will be acid form. Uh, then we have what are the typical quantities of gases released from the waste stabilization of landfill. So basically it has given the different compositions of methane and CO2. So what will be the most probable composition?
Landfill means we consider open dump, na?
No, no, not open dump. Open dump will have a longer aerobic phase. We in landfill we are
If
considering
we are
as
considering landfill, then landfill the possibility of landfill, if we are sending segregated waste, I think the possibility of methane will be less only, na?
if we are sending segregated waste. So we are assuming
Inert.
no, here we are not particularly concerned about we are getting sending segregated or non-segregated waste. Normally, what is the composition like in landfill? There will be anaerobic digestion. In anaerobic digestion, what is the uh, in general average range of methane and CO2 generated? So if we don't put any organic waste, biodegradable waste, then there will be no methane.
Yeah.
So that
But if we consider landfills, say scientific landfills are there, then mm, uh, practically it is considered that very less food waste will be there.
mm,
So I don't know, maybe between B or C, it may be, I think, 40 or 60.
mm, like in general in anaerobic digestion also the range varies, but the value sir reported in the class was on the higher end. So in India, most of the waste, most of the like food waste is going to landfill only. For in our environment, and the value reported by sir in the classroom was a 60% methane and 40% CO2. Although it's like we can, if the organic waste is comparatively less biodegradable organic waste is less, then obviously methane concentration will go down. But the average value which is seen in the ranges uh, for methane and CO2 generation is which is reported by sir in the class was 60% methane and 40% CO2. Next question is in the TCLB test, the solid waste particle size is reduced to less than 1 centimeter. And the reason is the finer particles have more surface area that helps in improvement of reaction rate. You have to determine which either assertion is true and if the reason is a correct explanation.
Sorry, 1 minute.
Ji.
In the TCLP test, solid waste size is reduced to less than 1, 1 centimeter. The finer the particles have more survey. R is the correct explanation, and both TCPL 1 centimeter less than. Yeah, both are correct. A
Yep.
A is the right answer.
Yep. So in TCLP test, we are basically before dumping those artifacts into landfill, we are doing TCLP test.
We are grinding it, so reducing the size
Yeah,
of less than one.
yeah. So less the smaller the size, more will be the surface area, more will be the chances of reaction. So the best TCLP test is basically overestimates. Uh, the idea is also uh, to get a value like not being on the side of underestimation, because if in landfill we put something which leaches more amount of certain chemical or compound, then it goes to groundwater, then it's not right. So TCLP basically overestimates the amount of leaching. So for that we need more and more, like maximum amount of reaction that can be possible, which will basically uh, signifies the more amount of reaction and more amount of leaching into the 2 liter solution we take, which is of acetic acid and NaOH. So based on that, both those statements are correct, and R is the correct explanation of A also. Next is TCLP test simulates the worst case scenario of the waste leachability within the MSO. We just discussed.
Yeah, it is true.
Yeah, TCLP is simulating the worst case scenario, because we are reducing the size very small so that more surface area is there, more leaching is there. We are not reducing size to less than 1 centimeter when we put in landfill. So we're trying to simulate the worst scenario so that more maximum amount of leaching can happen. So it's true. So why is waste to energy conversion unsuitable for waste with high moisture content?
Because letting heat of vaporization is required to remove the water.
True, true. Because water will be in liquid form in the waste, and when we burning it, we will take out latent heat of vaporization from the heat content.
So B will be the right
Yeah, so
answer.
B will be the right answer. Why do we perform ultimate analysis for solid waste?
Ultimate analysis. Or it will be B for quantification of gases, or even chemical formula. Both
Yeah,
A
we
and B.
have, yeah, both and B, to estimate the chemical formula of solid waste, and as well as to do the quantification of gas produced on degradation of solid waste. Both A and B is true. Next, we have a numerical fuel moisture content of solid waste is 68%. The initial weight of the waste sample with crucible is 50.23 grams, and the dry empty weight of the crucible is 30.60 grams. Calculate the over-dried weight of the solid waste, excluding the crucible weight.
We have to first subtract this 30 from 50, and then whatever is left out of that 68% we have to remove moisture. So the remaining will be the dry one.
Mm,
Yeah,
yeah, yeah.
Wait, let me calculate also. Excel sheet. Ce923 minus 19 into 68%, 13 minus, yeah, 6.27.
6.27 is correct. Next question is ignitability, corrosivity, reactivity, and toxicity are characteristics of dash waste. This we did in second class.
Corrosivity, reactivity, toxicity, all are hazardous waste.
Hazardous waste. Hazardous waste. Correct answer. If the energy content of solid waste as discarded is 210 kilojoule per kg, find energy content on a dry basis if moisture content of the solid waste is 9%. Also find energy content as an ash peak dry basis if ash content is 6%.
Zero. The moisture content is 9%. 991. Unit solid waste is 2. It's first one, 182 and 197.
नहीं बी सही है अगर मतलब बी ठीक होगा मतलब कम तो होगा नहीं क्योंकि सॉलिड वेस्ट है अगर उसको आप ड्राई कर दोगे तो उसका एनर्जी कंटेंट बढ़ेगा ही मॉइस्चर कंटेंट
ओके मैं उल्टा उल्टा कर दिया मैं उसको मॉइस्चर राइट कैसे कैसे करेंगे ये
आप 210 के लिए ये 100 केजी के लिए टोटल जैसे 100 केजी 100% वेस्ट के लिए तो वहीं अगर हमको निकालना हो 9% मॉइस्चर कंटेंट हटा देंगे तो 210 इंटू 100 डिवाइडेड बाय 100 माइनस 9%। तो ये आपका ये हो जाएगा 210 इंटू 100 डिवाइडेड बाय 91। तो ये आ जाएगा आपका 230.76। मोल कॉन्सेप्ट की लगा देंगे तो 210।
ओके, आप मतलब 210 100 में है तो 210 81 में कितना होगा? अच्छा ठीक है,
हाँ,
मैं मॉइस्चर हटा के उसको वैसे करने लगा।
उसके लिए अपन को फिर वैल्यू चाहिए होगी जो अपने पास है नहीं, फिर उस वाले रास्ते से जाएंगे।
0.91 इसमें 210 किलो जूल पर केजी है। अगर इसको हम ड्राई लेंगे तो ये मॉइस्चर हम लोग उसमें से माइनस करेंगे, मतलब 100 की जगह पे इसका वॉल्यूम 91 हो जाएगा।
91 हो जाएगा तो 100/91 हो जाएगा सीधे। इसके ही प्रोपोर्शन में एनर्जी बढ़ जाएगी।
100 divided by 91, 210 and 09, 230, okay, 230.76।
फर्स्ट पार्ट के लिए वो हो जाएगा। सेकंड में से पूछा आल्सो फाइंड एनर्जी कंटेंट एज ऐश फ्री ड्राई बेसिस। तो ऐश कंटेंट 6% है और ड्राई बेसिस भी पूछा है।
230.76 आ रहा, मतलब आपका बी ऑप्शन वाला में है क्या?
नहीं 231 ही आ रहा है। 230.7 है तो 231 हो जाएगा।
राइट राइट, ओके, मैं डी
हम्म,
समझ रहा था इसके। ओके,
और
और फाइंड द
दूसरे
कंटेंट, एस कंटेंट इज, वो सेम, फिर इसका भी एस एस माइनस कर देंगे उसमें से।
हाँ तो इसमें ऐश फ्री भी होना चाहिए और ड्राई भी होना चाहिए, तो दोनों को ऐड करना पड़ेगा। 9 + 6 15%।
3 और 15 माइनस करना पड़ेगा।
हाँ वही 100/85 इंटू
247.05, ओके।
आज यहीं पे रुकते हैं।
और ये बी वाला हो गया।
इसका आंसर है बी, करेक्ट। ठीक है सर, आज के लिए यहीं पे रुकते हैं। नेक्स्ट क्लास में और जो फिफ्थ वीक है उसमें ट्रांसपोर्टेशन इसके रिगार्डिंग सर और क्वेश्चंस करवाएंगे उसको, वो अपन जो और अच्छे क्वेश्चंस हैं, फॉर्मूलाज नए फॉर्मूलाज बताएंगे वो।
उसमें थोड़ा सा अच्छा था, सर ने जो फिफ्थ क्लास के जो भेजे हैं वो देखा मैं, काफी सारा एग्जांपल सर ने उसमें ट्रांसपोर्टेशन रिलेटेड दिया है।
हाँ तो वो न्यूमेरिकल्स अपन अगले वीक करेंगे। आज के लिए यहीं रुकते हैं।
ठीक है। आ, ये मेरे को ना थोड़ा 5-10 मिनट लेट हो जाता है, तो आप अगर हो सकता है तो वेट
हाँ
कीजिएगा।
हाँ सर, मैं करता हूँ, 10 मिनट तो मैं वेट करता हूँ।
आज
वो
मेरे को काफ़ी लेट हो गया
काफ़ी
क्योंकि
टाइम हो
मतलब
गया।
प्रोग्राम में था तो खत्म नहीं हो पाया, लेट हो गया थोड़ा, तो
कोई
इसलिए।
कोई दिक्कत नहीं सर।